of all, I will introduce you, like Suhail Alsalehi. We both studied at the same university, at Bangladesh State Technological University, and then he went to continue his studies at Skoltech. After that, he was a researcher or a researcher at MIT, on robotics, right? You did some great work, exciting work and researchers on robotics at MIT. And now you are doing your PhD on multi-agent system, robotic systems at Boston University. So it's my pleasure, our pleasure, to have you with us not today. Therefore, over to you. We are listening.
Thank you, Jose. Thank you very much for inviting me, and thank you everyone for coming today. Like for allocating some time to come and listen to the presentation that I will give today. Yeah, as Jose mentioned, like we studied together, and it's a great pleasure to be here, like to talk to students. I'm always happy to talk to students, to know what their ambitions are, what their goals are, and to help anyone that with any questions. So today, like I'll be talking about a project that I'm working on, which is how robotic teams can work towards common goals. As you can see, like you can have a robot that works for to achieve something, but you can have also multiple robots that are doing the same thing. So I just wanted, before I start, I wanted to get to know like everyone a little bit more. If you can just type on the chat, what is your major? What is your favorite course so far? And one thing that you want to learn today, like, or you hope to learn today. Let's see.
Let's see, great. So
I'll open the chat on my side. Yeah, guys, don't be like, just write anything. Even one of these questions. I just want to see how.
Should I write us or not? Should I write?
Yeah. Write in the chat.
Okay. Let's see who.
Yeah, anyone, just anyone. If you can, like, if you have a keyboard in front of you, just type. Tell me, like, what is your major? What's your favorite course? Just one of these questions. Just answer one of them, and we'll see. Okay.
We have.
Yeah, no, I mean, are you studying, for example, electrical engineering or mechanical engineering, mechatronics, control, something like that? Yeah. Thank you, Diego. If you haven't chosen your major, it's fine. You can say what you want to study in the future, like what you want to major in. You can also unmute and talk if you want. Wait, there aren't many people here, so you can unmute and say.
Okay, Diego, can you talk and try to answer those questions?
Yeah, just one of these questions. It doesn't have to be something big.
Can you hear me well?
Yeah, hi Diego, hi.
Okay, this is faster than typing. Thank you.
Yeah, thank you.
Okay, my major, I'm currently studying mechatronics engineer. I'm in my the end of my 4th year.
Okay.
Cool. I think I have like not one favorite course, but like branches in general. But I really like robotics.
Okay, that's cool.
Electronics, mechanical design, and manufacturing in general.
Oh, that's cool. That's cool. That's like a broad set of subjects. But yeah, that's cool. Yeah. And do you plan to go to do your master's afterwards, or you want to work a little bit? Or?
I really don't know, because I haven't found like a specific master I would like to attempt, but I don't know. If I found one that like is is like
Yeah,
in that area, I would love to. Yeah.
that's great. That's great.
And
Good luck
one
to you.
thing, thank you. One thing I would like to learn today is, first of all, like I think you will explain it later, but how is a robotics team, uh, like which are the main parts of a robotics team in terms
Uh-huh.
of activities, or I don't know, what which areas you have to cover, like one person or two are like part of the in charge of the electronics,
Uh-huh.
another one of I don't know, the mechanics, or how is it conformed, robotics team, and basically
Mhm.
what could they achieve, like that. But I
Okay,
think like
okay.
you will answer this
Yeah, I will
further
try
in
to
the
answer your
presentation.
questions. Thank you. Thank you, Rodrigo. Thank you. Thank you,
Thank you.
Diego. Yeah, and Leonardo said like he's studying mechatronics and he loves programming. So that's great. And Richard also answered. And Rodrigo also said that his favorite subject is automation. So that's great. Like, and Rodrigo wants to learn about the KPIs for industry. That's really great, actually. Yeah, the KPIs are very important when you go to industry, especially if you want to do some business or something like that. So yeah, let's see what we'll talk about today. I will give you this. I will give the talk that I prepared, and then I will open for questions afterwards. If you want to talk about anything, we can talk about it. If you want to know how to apply for internships, for scholarships and stuff like that, I have been like around for a while and I did that many times, so I can help you with that as well. But let's go to today's presentation for now. So today we'll learn about how we'll learn about how a team of robots is an example of multi-agent systems. So as Jose mentioned, like in my research, I study multi-agent systems. A team of robots is just one example of this, and I will show you other examples of multi-agent systems. And I will show you how to write requirements for such systems in a machine language. So imagine you have lots of robots and you want to express to the computer or to the microcontroller inside the robot some requirements, like you can tell it, for example, to move from this place to the other place. So we will learn today about how to write these requirements in a machine language. We will learn about optimization. I think some of you might heard about optimization, but I will explain it a little bit, and how we can use it to control robots, basically. And also, I'll give a small part of this presentation to talk about neural networks and how we can use them also to control robots. Don't worry if you don't have a background, it will be very simple. And hopefully by the end of this presentation, you will have some idea about each one of these 4 points, okay? At any point of the presentation, if you have a question, just stop me. If I'm speaking fast, also stop me, and they can slow down and they can explain anything. So a little bit about myself. So I love football, like soccer, as they call it here in the US. I played football like for a long time. I also love swimming. I love sunsets and traveling. Over the years, about my background a little bit. So I grew up in Yemen. That's like my home country. Yemen is slightly bigger than Bolivia in terms of population and area. So you can Google that and you will find some information about that. Then after I finished high school, I moved to study in Russia, where I studied in Bauman Moscow State University. I studied there for undergrad in mechatronics. Then I did my master's as well there in Russia, but in a different university, Skoltech. From Skoltech, I worked a little bit at MIT in Cambridge, the United States. And I also worked a little bit in Germany on designing satellites. And the picture that you see here is a small CubeSat. This is a CubeSat that I helped designing some parts of it. And then where I am now, after I finished my master's, I moved to do my PhD at Boston University in multi-agent systems, which I will cover part of it today as well. So this is my background. My research is mainly on multi-agent systems, but I like always to divide it in multi-agent systems into multi-agent robotic systems, and there are also other multi-agent systems. So today I'll be talking about multi-agent robotics systems, as I mentioned. So basically you have multiple robots. This is a very simple figure here. You want them, for example, to avoid obstacles, to communicate with each other, and to reach some kind of area here. For example, this is just a simple example. Other examples of multi-agent systems, this is another project that I work on, and it's like my favorite project actually. And I can talk about it like on the side later, like if somebody have questions. But in this project, we are studying how to create human organs in the lab settings. So we start with simulation, and then we try to replicate this in experiments. And eventually, like the goal that we are trying to achieve is to create human organs in the lab. So you see how engineering also and mechatronics can lead to some biological stuff. It's not only about robots. Okay, so moving on. So next, I will start talking about the multi-agent robotics systems. And we'll talk specifically about how to control these systems. So let's formally define a multi-agent system here. So first of all, what is a system? A system is basically a form and a function, and you have some kind of results from this system. For example, if you have a robotic arm and you have wheels and you have a camera, these are the form, these are the parts of the robot. And then the function, for example, you wanted to locate, for example, the phone on the table and pick it up. That's the function. And the cool thing about systems is that if you have only an arm, for example, a robotic arm or a camera or like something else, each one of them cannot do a big task. But if you combine them together, you have this thing that's called emergence, which is you get some benefit that's much bigger than what you would get by having just a robot or just the robotic arm or just one part of the robot. However, systems are not only robotic systems. So you have some natural systems like the water cycle. You have some robotic systems, which is just one example of the systems. You have also some biological systems. So I'm doing research in both of these areas, in like robotic systems and biological systems as well. You can also do some mechatronics research somewhere here in the natural systems, probably, if you study them. So I wanted to give you just some examples of multi-agent robotic systems. So you can have something like a military base where you have, for example, autonomous tanks, you have ambulance, you have drones, you have airships, and they're communicating amongst and telling each other where they are, what they are doing, what is their next step. So this is one example of a robotic system. Another example, if you have satellites in the sky, for example, Starlink is a satellite constellation that was deployed by SpaceX. This kind of satellites also, it is a multi-agent robotic system because you can a little bit control the orbit of these satellites, and they communicate among themselves and so on. Another example is smart cities. So if you have smart vehicles and they're communicating amongst themselves, and they are giving each other information, and they're communicating with the city itself, with communication towers and so on. This is another example of multi-agent robotic systems. And one of like the favorite that people now use a lot, which is drone shows, where you have hundreds or thousands of drones and they make shapes and in the sky, like if you are celebrating something, like some countries are very popular with this. So instead of using fireworks, you can use drones and draw some shapes in the sky. So this example that we talked about here, some of this, there is a subset of multi-agent systems, which is mobile ad hoc networks. It just the same as before. I just am defining it formally. So here you have the agents are connected wirelessly. You can see here, for example, the drone is connected to the airship, it's connected to the ambulance is connected to the base, and so on. They have some kind of wireless connection. And each one of them is doing different tasks. So for example, the drone can be monitoring, the tanks can be, and the airship can be, for example, doing some observation over the whole area. The ambulance can be, for example, helping soldiers and so on. So they are doing different tasks, and for each one of them, they have different equipment. So the drone has a camera. The airship might have, for example, a wireless transceiver. The ambulance have nurses and people inside it that are helping soldiers, and so on. And this kind of multi-agent systems, the agents are moving independently. So the tanks are moving independently from the drones, from the airship, from the ambulance, and the communication link can change over time. So for example, now these two are connected, but after some time, these two might connect, and so on, and the connections might change over time. So that's something to keep in mind. And this class of multi-agent systems, this type of multi-agent systems is called mobile ad hoc networks. So don't get confused. This is just another example of multi-agent systems. To give you some description of this system, if we want to formally describe it in some mathematical, we give it some mathematical formula, because we engineers, we always like to give to study the math behind stuff, right? So you have a team of n robotic agents here. You can see them. Let's say n equals 10. We have 4 tanks, 2 ambulance, 2 of this, and 2 of this. You have some state of each agent. The state of the agent can be either constant attributes. So you can say, this is an ambulance, this is a tank, this is a state, this is a constant state. A variable attribute, which is the variable state that changes over time. This is, for example, the position of the ambulance. Now the ambulance is here. The next time, in 10 seconds, it will be in a different location. And this is what we call the variable attributes. And you can see here how we capture it with an Euclidean space, for example. And you can see here that the constant attributes, you have either a tank, ambulance, drone, airship, or tent, and so on. And then each one of these agents or each one of these systems have some dynamics. And then I think we all know how the dynamics work. I think if you have taken a control course, you know how to describe the dynamics of a system using a function. So here we have each system has a function that describes the dynamics of the system. And then we have some connectivity condition, which basically tells you when 2 systems are connected. So in this example here, we can say that 2 systems here are connected if they are within a specific radius, if they are within a specific distance. So if the ambulance is, for example, 10 meters away from the tank, there is a connection link. There is a connection link between them. And so on. So one question that arises is, how do we specify requirements? How do we tell each one of these systems what to do? So in a human language, you can look at something like this. You can say that the drone should always monitor tanks and soldiers, then goes to the charging station every 30 minutes. So basically what this says is that the drone has to look at this, and then it has to look at the soldiers, and then it goes back to the charging station, which is the tent here. So 3 steps basically, and it has to do this every 30 minutes. Okay, so this is the requirement in a human language. You can have other things like if there is an emergency, the ambulance has to reach soldiers in 5 minutes, and so on. So this is in human language. How do you translate? The question is how do you translate this to a computer language? So we all know that computers do not speak our language. They only speak 1, 0. So we have to translate this to their language so that we can describe this to the robots. And okay, I'll talk about the easy way to do this. So the easy way to do this, it's not easy really. It can get really complicated, but you can use if else statements. If you're coding, like you said, some of you said they love coding and stuff. When you use if and you give a condition and then you give a task. For example, you can say if the ambulance is if the state is this, then this happens. So this if else statements, you can use them to write these requirements, but you will have to somehow encode the requirements in a computer language. So this is a very hard task. However, fortunately, the research that I'm doing, and a lot of people are doing in this field, is how to write computer language that's very close to human language, so that both the computer can understand it and the human can understand it as well. And this field is called formal logics. So you have like in a human language, you have some words like the semantics, and you have syntax. So you have words and you have grammar, basically. The words that you have here are, some of you are familiar with this, I think. So this is not, this is the logical operator not, this is the logical operator or, this is and. So you can say something, you can say not ambulance, or you can say ambulance and drone, for example, and so on. So these are some logical operators here. Another example is temporal operators. So you can say something like eventually, like at some point in the future, something happens, or always something happens. And there are also some spatial operators, like in space. So this is in time, this is time, this is space. So these temporal operators here, for example, reach and escape. I will not talk about them a lot now, but we will see an example later. So let's have a look at one example. We can say, for example, that this is supposed to be black. So black agent has to reach the black, this one's like 2 or 4, have to reach the red one. So there has to be a connection between them, between red. Okay, so this is one example of requirements that you can write. So as I mentioned, you have syntax and you have semantics. The semantics is like the grammar. So we have qualitative semantics, which tells you if the requirement is satisfied or not. So for example, we said that the black agent has to reach the red agent. Okay, so black has to reach red. Black has to reach red. You can look at this at agent number 2 because it's a black agent and it has a connection to red agents. So this is satisfied. We say that the requirement is met. So we meet the requirement. However, agent number 6 does not meet the requirement because it's not a black agent. Okay, so far what we have figured out is how to write the requirements in a computer language, and also how to check if the requirement is correct or not. Okay, so we already know these 2 things. There is a small addition to this. So instead of saying only this requirement is satisfied or not, you can say how much it was satisfied. So how well you did the job. So imagine, for example, in exams, there are some subjects where you have pass or fail, and there are some subjects where you have like A, B, C, like grade. It's the same here. So the qualitative semantics tells you like you either pass or fail. The quantitative semantics can tell you whether you have an A or a B or a C, whether you got 90% or like 100% in your test. So it's the same thing. So now we are able to do this. So now we did this. We can now translate from human language to machine language, and we can write it in this way. So as we said before, the drone should always monitor the tanks and soldiers. This is how to write it basically in a machine language. This is called the formal. This is called formal logic formulas. But basically, we translate it from human language to a robot language, to a computer language. Okay. So now that we have translated this requirement into a computer language, we want to know, like, we want to control these robots so that they would achieve the tasks that we ask them to do. In order to do that, now we have a system, we have N robots, And we have this formula that we just wrote. Remember the formula that we just wrote? And we have some cost function, basically. And from here, we can, we want to find the control that that makes these robots achieve our requirement. We can formulate this as an optimization problem. I hope some of you have heard of optimization, but if not, I will talk about it a little bit now. So optimization, basically, to put simply, it's basically you have a function. Imagine that this is a function. For example, this is x square. Let's say this is x square. When you plot x square, so this is, for example, x. This is, for example, y. Oh, sorry. Let me write this again. So this is, for example, y. This is y equals x square. This is, okay, x square plus 2. This is x here. So this is a function. And what optimization does is you basically are trying to find the smallest, the minimum or the maximum of the function. So if I give you a function like this, and I tell you to do optimization on this function, you're basically trying to find the smallest point or the largest point of this function. Okay, very simple. However, like people study optimization for years. People sometimes do PhD in this in optimization. So yeah, so this is an example. Things can get a little bit more complicated if you have more complicated functions. So if you have a 3-dimensional function, you can see here, for example, you have more than one minimum point or one maximum point. So you have here a maximum, here a maximum. You have some minimum points. So it gets a little bit more complicated. But that's not our issue today. Today, we just want to know that there is something called optimization, and it is about finding the maximum or the minimum point of a function. Okay, so let's move on. So in my problem that I defined, choosing the optimization algorithm is critical, and we'll see like now why. So these are different types of optimization algorithms. If you have learned and if you have taken an optimization class, this is basically a gradient-based optimization. This is a heuristic optimization algorithm, and this is a hybrid algorithm. And so you have to be very careful when you choose the algorithm, because depending on the algorithm that you choose, you can get different results. So the success rate here is how often do we meet the requirements. So if you have when you are using the gradient-based method, we often failed. So this is 44% of the time we have success, and more than 50% of the time we fail. The same with this, it doesn't do really well. And the best performance that I got was with the hybrid algorithm, where I used the heuristic approach and the gradient-based approach. However, let's have a look at the time of the performance time. So we are controlling, for example, we're controlling the ambulance that wants to go to a patient, for example, very quickly. And if you are trying to solve the optimization problem, you can see here that the optimization time can be, for example, 30 seconds. 30 seconds is a lot of time if you are trying to solve an emergency, or if you are trying to control a tank or something very quick. So this is not a very good thing because it's very slow. But is there another way that we can do the same job so we can control robots without much faster? Basically, we want to control robots much faster. And yeah, some of you might be asking, like, what is this plot here on the side? So here you see these are, for example, these are just robots, agents. These are also agents, different agents. Each color has a different task. And what you see here, this is basically the borders of each agent. And yeah, so basically this is just an illustration of 2 robots trying to navigate the environment and reach some area. You can think of them as 2 ambulances. And here you have this, for example, the injured soldier or something like that. Okay, so we said that we want something that's faster than optimization. So what can we do? We can use neural networks or artificial intelligence, which is basically what it does. So some of you might have taken machine learning classes. If you haven't, I will just explain this very simply. So a neural network, basically, you gave it a lot of examples. So you gave it an example, you tell it, for example, you can give it a cat picture. You can give it a cat picture and a dog picture. So this is cat, this is dog. You give it a lot of pictures of cats and dogs, and you tell it this is a cat, this is a dog. You feed a lot of pictures here, and it will tell you later, like once you finish training, you can give it a new picture. This is a test. Now you want to test it, and you give it a new picture. It has something that looks like this. Sorry, my drawing is terrible. But this is, to me, it looks like a cat. So let's say we want to test the neural network, and it should tell us at the output, it should tell us this is a cat. So this is basically when you test it. So you have to train it first on examples, and then you test it on new data. And what I want to do is to give it a lot of examples of successful runs. Let me go back to the previous slide. So I will give it a lot of examples when we have done this successfully, when we achieved the task. And then I wanted to learn the control, basically. So I did that using some LSTM, which is basically a type of neural networks. The result was much better. So now you can see that it's much faster, basically. So you can see that we are achieving the same, almost the same success rate, but we are much faster. So now within 0.2 millisecond, we achieve success. So it's much faster compared to 30 seconds. So that's a great result that we achieved. So talking a little bit about LSTM. LSTM basically is a neural network. It's a neural network, just a type of neural network in which you can feed it time series data. So we have, well, for example, what I feed it here is the trajectory. This whole thing, I give it this, and they tell it at time 1, time 2, until time the final time here. And I give it this whole trajectory. I give it, for example, in this case, I trained it on more than 1,000 examples. And it learned basically the control that you saw now. And what you can see here in this plot here, let me show you this again. What you can see here is like the dashed lines. These are the ones generated with optimization. And the solid lines, these are the ones that are generated with the neural network. And you can see that the neural network learned a very smart, it did learn a very smart way to navigate the environment better than the optimization. So that's why people like neural networks. They use them a lot. There are some drawbacks to neural networks, but yeah, we can talk about them like in the Q&A section if you want. So yeah. Basically, that's the research project, like one of the research projects I'm working on. And today you learned about the definition of a multi-agent system. We also learned about how to specify requirements in a machine language. We learned about how to control robots using optimization and how to control them using neural networks. And with that, I would like to give some time for questions. Feel free to ask any questions in the presentation or outside of the presentation. And thank you for listening.
Thank you very much, Suhail. It was awesome.
Thank you.
Please, if you have any question, you can either put it in the chat or just ask yourself. The microphone is open.
Yeah, feel free to unmute and talk. I think that's better. That's
I
faster.
got a question.
Yeah, hi, Leonardo.
How does this result generalize? What I mean is, let's say we want to develop a system. Do you always recommend to develop a neural network to control the system, or gradient descent, or some other algorithms?
So you mean in generalizing this algorithm to other systems?
Yeah, what I mean is, let's say we want to develop X system. with drones or whatever, is it always recommended to use neural networks?
Not necessarily. It depends on the case. So if you want to learn the controller offline, if you want to run it online, I think it's better to use neural networks because they're faster. However, like this is not the case all the time. So sometimes you have a system that you want to run offline. You don't have to respond to some new tasks or new initializations. So you can basically use optimization if you don't care a lot about time. So if you have, for example, a smart city and you have some requirements that you designed and everything, if you want to make some decisions for a smart city, for example, where to move the traffic, where to, for example, direct the ambulance and everything, you don't really need to be that fast, like 0.002 seconds. You can use optimization. I will tell you like why neural networks might not be the best option, because for neural networks, you have to generate the examples first. So in this case, I generated 1,000 examples to train the neural network. To generate these examples, I needed about like 6 hours to generate the examples for this one. So it depends on your case. The short answer is it depends on which case, what are you trying to use it for. But both algorithms work fine, and it only depends on the case. Yeah, thank you, Leonardo, for the question. Did they answer your question?
Oh yeah, thank you.
Okay, great, thank you.
Did you try to solve that problem using deep reinforcement learning?
That's what I'm doing now, actually.
Yeah.
So I'm working now. So instead of generating examples and then training a network, the new architecture that I'm working on is, let me roughly draw it here. So we'll have this network that will act as a controller. So this is the controller. And then I will have another neural network, which will act as the model. And I will try to use reinforcement learning to basically learn this controller online. So instead of generating examples that will later be used to training, you will deploy the system and then you try to learn the controller online. So like in live manner. Yeah.
When you say online, do you mean on a real robot or on a simulation?
You can do it on a real robot, but you know it's expensive to break robots.
No, I mean, yeah, I understand that. But what I meant was, did you run those experiments on real robots or?
No. So what we do usually is like you start in simulation. So you start training it on simulation and then you put it on the robot. And you have to be very careful because, for example, when I train it on drones, the drone, like if it makes a mistake, the drone will hit the wall and then the drone will break. So I usually put it in simulation first. I first do it in simulation, and then when I'm very confident that it already learned the good controller, I send it to the drones.
It seems like you're using MATLAB, I guess, right? Or Python?
So for the optimization, I used the MATLAB. For the neural networks, I like more to use Python. Also, like MATLAB also has functions that you can use for neural networks. But somehow in my brain, there's already a division between MATLAB. I use it for control, for optimization, for stuff like that, because it's very good for modeling. And then for neural networks, there are lots of good packages in Python. So it's much easier to program it there.
What are you using, PyTorch or TensorFlow?
Both PyTorch and TensorFlow. But for this example, I was using PyTorch.
PyTorch. So it depends on the task. You want to use TensorFlow or you want to use PyTorch, or it depends on what?
Yeah. So I usually prefer, like when there is if you're using a huge, if you will need to make very huge computations, TensorFlow is usually better because it has, what I like about it is that you don't have to worry about the GPU, using GPU or parallel or something. It manages this by itself. So if you have a GPU on your computer, TensorFlow will find it out by itself, and it will run it on the GPU. However, PyTorch also has GPU, but you will have to write your code so that it will be only on GPU. And then if you want to run it on a CPU, you will have to make some modifications on the code. So it depends on the case. But here in this case, I used PyTorch because the computation is not very expensive, really. So I could run it on my personal computer. I didn't have to run it in a cluster or anything. So that's the reason why I used PyTorch in this case. Excellent.
Thank you very much, Suhail. I don't know if there is any other question from our audience.
Yeah, if you don't have, I mean, you should have some questions sometime. If you don't have any questions now, but you have questions for later, you can always reach me. Like, this is my email. And if you scan this QR code, you also can find, this is my LinkedIn. I'll be happy to connect with you guys. It's always a pleasure, like, to connect with everyone, like, and answer questions. So don't hesitate. Okay.
Suhail, could you please give some recommendation about internship, how to apply to internships or university or something like that to our students?
Yeah, so I think there are a few steps that when you are trying to apply for internships that you need to do. First of all, you need to be really strong. You need to really learn the subjects that you are studying at school. So what you're studying, for example, if you're studying MATLAB, you have to be like really good in MATLAB. If you're studying Python, you have to be really good in Python. If you're studying control, you have to make sure you're really good in control. And then, so the first step is that, like, this is a very obvious thing. I think everyone knows about this. And then once you have a very good background, you have to know how to present yourself in a good way. So when you write your resume, it's very critical that you write it in a very good way. And it's always good to ask for help. So for example, you can ask me, you can ask Jose, you can ask somebody who is already senior. So if you're, for example, in a first year or second year from your university, you can ask your friend who is in fourth year or who is doing a master's, or you can ask your professor even. Some professors would do that for you. Like, just ask for help. Start somewhere and then ask for help. Most of the universities have resources for this. I'm sure you have some resources for this. You have just to ask. So you can ask for help with the resume and everything. And once you have a good resume, so now you have strong background, you have strong understanding of the subject, so you have good skills. And now you have a good resume. Now you have to look for positions that really fit your background. So for example, you want to work in mechatronics. You have to find positions that are for mechatronics people, or positions where you have some kind of match or some fit. One mistake that everyone does is when you read the requirements for the job, you think that you have to meet them all. The reality is you don't have to meet all the requirements on the job description. So let's say, for example, the job description tells you that you have to know Python, C, and MATLAB, and you have to know all of these kind of things. Most of the time, if you know one of them, that's enough. So you have to try. That's my suggestion for you, is like, you have to try. Even if the job description you don't cover every point. Nobody does cover every point, because the recruiters, people who hire, they always want to have the best people. So they write everything, like their dream employee. But they don't always find their dream employee. They have to compromise for something a little bit less than what they require. So that's the third point. So to recap, basically, you have to know the subjects really well, you have to have a good resume, and you have to apply. And the fourth thing is you have to apply to as many places as you can. Everywhere, basically. Don't be afraid to apply, because you already have your resume, you already have the skills. Just apply. You don't lose anything, basically. Just apply to 10, 20, 30 places, 40 places, 50 places. It doesn't mean anything. And my fifth and final advice is, once you apply, forget about the application. Don't wait for a reply. Just keep it somewhere in the back of your mind. If they didn't reply to you in a week, send a reminder to them, send a follow-up, ask them like, hey, I'm sorry, I applied for this position, but you haven't replied to me. Most of the time they will reply to you and tell you like, oh, we are sorry, we will look into this. If they don't reply again, wait for another week and ask them again. But basically the fifth point is forget about the applications. So you apply to 50 positions. If they all reject you, it doesn't really matter. Apply to another 50. Okay. Hopefully that makes sense. These 5 points.
Yeah, awesome. It is a really helpful advice, I think, for all of us.
Yeah, I mean, when I applied for universities, for example, for the PhD or something, I didn't apply to one. I had to apply for like, I think I applied for 6 or something. I got rejections from 5 of them and only 1 of them accepted me. The same with internships. You apply for like, I applied, I think, for like 10, 15 positions and I got only 1 of them. So you have always to apply a lot. And I was lucky to get 1 position out of 15. There are people who apply for 100 positions and then they get 1. So yeah, don't give up. That's the main advice.
Yeah, awesome. Thank you very much, Suhail. Let's I don't know if we can wait for some questions from our audience. What do you think?
Yeah. Actually, I wanted to ask Jose, like, this was supposed to be 45 minutes or 1 hour. I prepared like for 45 minutes, like the presentation. I could have talked a little bit more.
It was 45 minutes, like.
Okay, that's good. Yeah, I can also. I have showed you my. If you want to connect, you can send me the email. Yeah. Or you can also connect with me on LinkedIn. You can ask Jose, like we studied together with Jose and we are like very good friends. You can ask him to connect you to me if you have any questions and they'll be happy to answer them.
Thank you. I really appreciate your presence now today and thank you very much for the exciting presentation.
Yeah, thank you, Jose. I hope like everyone learned a little bit something, hopefully.
Thank you again, Suhail. We appreciate it. If there is no questions, so we can end for this presentation. And from me and from the Mechatronics department here at the University in Bolivia, we want to say just thank you again. And in the future, if possible, collaborate in some of the projects.
Yeah, great. I'm very happy to collaborate on any of the projects. If someone wants to talk to me about the projects like separately, I can also talk about them in more details. Thank you for inviting me and I hope to see you again sometime soon.
We hope so. Thank you, Suhail.
Bye.
Bye-bye. Thank you.